Okay, welcome back, and we're going to actually solve some equations using reference angles. And I just had done a video prior to this which did a little bit with inverse trig functions, so you see where these come from. Okay, so the first thing we're going to do is we're going to solve for these equations, but we're going to solve these from 0 to 2 pi. So this one's in radians, and we're going to use reference angles. So if you have your table handy, you can do this. So basically, when you solve these, you're like solving a normal equation, except for you're basically solving for the angle. And because you're talking trig functions repeat and repeat and repeat. Sometimes you have one answer, sometimes you have no answers, and sometimes you can have 2, 3, or sometimes 4 answers for this, because more than one angle can work in certain instances. So the first thing I want to do is we want to solve for theta. So I'm going to divide each side by 4. By doing that, I have the cosine of theta plus 1 equals 0. Because if I divide by 4, that's going to be 0. Now, you're going to do the cosine of theta equals negative 1. Okay? So the first thing I want you to do is draw a picture. And when you have a 1, a negative 1, or a 0, you're looking probably at a quadrantal angle. So I know my unit circle. So I know over here that this at pi, this is the point negative 1, sorry, let me erase that, negative 1, 0. Okay? So if this is the point negative 1, 0, I know that if I put the cosine of pi in there and that angle, I would get negative 1. So the answer in this case is theta is pi, because I now found out that if I did the cosine of pi, I would get a negative 1. Okay? There's no other angle that works with. That's the only where cosine is negative 1. So that's the only answer for that question. Okay? Let's look at this one right here. So I want to solve for cosine of theta. So I'm going to subtract cosine of theta on both sides. So I have 2 cosine of theta, and then I'm going to move the radical 3 over here, so it equals radical 3. And then I'm going to divide by 2, so now I've come up with the cosine of theta equals radical 3 over 2. Now, what I want you to do after you do that, you have to look and see, well, where is cosine positive? And cosine is positive in quadrant 1 and quadrant 4. So I could potentially have 2 answers to this. All right. Now we are doing this in radians, so if I were to do inverse cosine on both sides, because I want to solve what this is on my table, and when I do that, I know it's the cosine of 30 degrees, or if you would say pi over 6. So I know that one of the angles is pi over 6, because that's here in the first quadrant. Now remember what I taught you. This is now 6 pi over 6. This is 12 pi over 6 and 0. What would the angle be here? It would be 11 pi over 6. So both those angles would work for this equation. Alright, so let's try a couple more. And I'm doing radians. We will practice degrees, but I want to practice radians here in your notes so that you'll understand how it works. Okay, here's the first one. I'm going to divide by radical 2. And if I do, I get sine theta plus radical 2 equals radical 2 over 2. Now if I subtract radical 2 on both sides, I get sine theta equals radical 2 minus radical 2, and if I had a common denominator, I'm going to end up with negative radical 2 over 2. Okay? Now this should look familiar to you if you're like, oh, that's 45 degrees on my reference table. So I look and see where sine is negative, and sine is negative in quadrant 3 and quadrant 4. So on my table, I know that pi over 4 is my reference angle, because the sine of pi over 4 is radical 2 over 2. So what would it be in these two quadrants? Well, this is 4 pi over 4. This is 8 pi over 4. So the two angles this could be would be 5 pi over 4 is one of the answers. And the other answer would be 7 pi over 4. Those two angles will make this equation work. Let's try this one here. I want to solve for tangent of theta, so I'm going to move this over here. So if I subtract 3 tangent of theta, I have 2 tangent of theta. And then move the 2 over equals -2. And then divide it, so I have tangent of theta equals a -1. And I know the tan of 45 degrees, or radical, pi over 4 is -1. So I know my reference angle is pi over 4. Where's tangent negative? Tangent is negative in quadrant 2 and quadrant 4. And if pi over 4 is my reference angle, what would they be in that quadrant? So I do 4 pi over 4, 8 pi over 4. And in this case, the two angles that would work would be 3 pi over 4 and 7 pi over 4. Now I know this is a little tricky. We will be practicing with degrees so that you get very comfortable with it, but I just wanted to do some radians with you because you're more used to degrees, so you need more practice. The last thing I'm going to show you is I have the cosine of theta graphed here. And I want to know when cosine of t equals 0.4. Well, that would be this dotted line right here. This is 0.4. And if you'll notice, it happens here, 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 and it keeps happening because it's sinusoidal. So if I do the inverse of cosine on both sides to figure out what that would be, the first one in the first quadrant, because this is quadrant 1, the angle would be, t would actually be 1.16. So I know the cosine, and we're in this in radians, so it's 1.16, is going to be the first time that this is 0.4. Then if I go over here, I'll notice the second time this happens, well, I shouldn't put quadrant 1. Let's put this T1 because that's what they called it. The second time this happens is going to happen here at T2, which is 6.28 minus 1.16, or it happens again at 5.12. And at T3, it's going to be 6.28 plus 1.16, or 7.44, and it can keep going, etc., etc. So once you find out when it happens the first time, it's easy to find the other two times by adding it, because this is 2 pi, and subtracting it from 2 pi. So those would be your solutions for this equation. So you have more than one. I should have actually done it down here. The solutions are here. So there's a little introduction to solving trig functions and practicing how you do that. And that will be the end.